So today we are going to be continuing our discussion about volume, and what we're going to do is we're actually going to be using estimation to solve for the volume of rectangular prisms. Our central question is, how can you use an everyday object to estimate the volume of a rectangular prism? So this lesson's a little bit different. It does have some really nice like practical applications to it. Like we don't always want to break out a tape measure and measure things in order to make sure that what we want to put inside of it's going to fit. So like it has a lot of good purpose. It's a little tricky at first. Sometimes it almost feels like it's twice as much work. Um, but I think we can figure it out together. So we're going to start with this problem, and it says that a crayon box has a length of 3 inches and a width of 4 inches and a height of 1 inch. So if we take a look at this, this one is 3 by 4 by 1, so it has a total volume of 12 cubic inches, right? So our crayon box has a total volume of 12 cubic inches. What we're going to do now is we're going to use the volume of this crayon box to figure out how much space this other box takes up. And you might not be able to see it very well, but down here, right, like we have the outline of another box that this stack of crayon box is sitting inside of. And so what we want to do is we want to figure out what is the volume of this larger box that's holding all of these smaller crayon boxes. So all we're going to do is this. We're going to take a look at it and we're going to say, well, in here, how many crayon boxes are there? It is 2 by 2 by 1, 2, 3, 4, 5. Right? So if we were thinking of crayon boxes as a unit cube, right, then we would say that this one is 2 times 2, which gives us a base area of 4. And then we'd multiply that by our 5 rows, right? So every row has 4 crayon boxes. 5 times 4 means that there are 20 crayon boxes inside of this larger box, right? So inside of each of this larger box, we have 20 crayon boxes. We also know that each crayon box has a volume of 12 cubic inches. So we would multiply the number of crayon boxes, which is 20, times 12 cubic inches, because that's the volume of each one. And here we're going to ignore the 0 for a second. 2 times 12 is 24. We're going to bring our 0 back. So the larger box in this picture that is outlined in red has a total volume of 240 cubic inches. So that's what we're doing today. We're going to find the volume of our smaller unit. We're going to see how many of those units fit into a larger box. We're going to multiply those two numbers together, and that's going to be our estimated volume for our larger box. Now, like I said, sometimes we might use this, right, if we were going to send a package to somebody, or we wanted to like store something in the attic or just put something away. And we would look at the size of a box and we would kind of guess, like, well, I think that this will hold about 20 crayon boxes. And then we would start to lay them in there and hope that they all fit, right? Well, this is another way that we can kind of use that technique to work through some of our math. Right. Our next one here, this one says that each tissue box has a volume of 125 cubic inches. So here they give us the volume of each of the tissue boxes. And then we need to look at our larger box and say, well, how many tissue boxes does it hold? And it's just one row, and we have 1, 2, 3 by 1, 2, 3, right? So this one row is 3 by 3, so there are 9 tissue boxes in our larger box. So what we need to do to find our total volume is we need to multiply 9, because that's how many tissue boxes fit in there, times 125, because that's the volume of each of these boxes. So I'm going to do that right here. So 125 times our 9 tissue boxes. That is 45. 18 plus 4 is 22. And 9 plus 2 is 11. So our larger box over here, right, that we kind of have outlined like this, has a total volume of about 1,125 cubic inches. All right, we have one last one that we're going to look at together. Why don't you go ahead and try to figure it out on your own, pause the video, and come back and we will see how you did. Okay, so this one, each book has a volume of 80 cubic inches. We need to look at our larger box and see how many books are in there. Well, there are 2 this way. It's 2 boxes this way, or 2 books this way, and then it is 1, 2, 3 books tall. So we have a 2 times 2, which is 4 for our base area, and then we're going to multiply that by our height of 3, and 4 times 3 is 12. So we have 12 books total. Each one has a volume of 80 cubic inches. So again, this is the number of books. This is the number of cubic inches that each book takes up. We need to multiply these. Again, we're going to ignore the 0 for a minute and multiply by 8. 8 times 12 is 96. And now we're going to multiply by that 10 from ignoring the 0 and bring it back. We get 960 cubic inches is the volume, the approximate volume of our larger box. We have one final problem that kind of pushes you to think a little bit more. And here it says that Marcel estimated the volume of these 2 boxes using one of his books. His book has a volume of 48 cubic inches. It says box 1 holds about 7 layers, right? So that means that box 1 holds about 7 layers, whereas box 2 holds about 14 layers. Marcel says that the volume of either box is about the same. Is he correct? Does this make sense or is it nonsense? Well, we can look at this and we see that both of these boxes have the same number of books laid from front to back. Both of them have 4, right? So we have 4 and 4. That's totally the same. Across the front here, this one is 2, whereas this one is only 1. So the one on the right is a 4 by 1 by 14. And the one on the left is a 4 by 2 by 7. Right? And the question is, are these 2 equal? Well, hopefully what we can see here is that if we take the second part of this and we look at 1 times 14, we end up with 4 times 14. We're going to do the same thing over here. We're going to use the associative property, right, to group this part of our problem together first. 2 times 7 is also 14. So we end up with 4 times 14. Now, if you use the same exact book to measure both of these boxes, and it has a volume of 48 cubic inches, then that means that they're both going to be the same. We don't really even have to do any more math because we know that the box on the left holds 4 times 14 number of books. The box on the right also has 4 times 14 number of books. And so that means that both of these are in fact equal. All right, so going back to our essential question, it is how can we use everyday objects to estimate the volume of a rectangular prism? And looking at their answer here, gone out. It says that I can use small rectangular prisms that I know the volume of as a tool to estimate the volume of a larger rectangular prism. I can find out about how many of the smaller prisms fit in the base and about how many make up the height. I can multiply these numbers and the volume of the smaller rectangular prism to estimate the volume of the larger rectangular prism. That's a super long way of saying that basically we're going to take the volume of our smaller prism and then we're going to multiply that by how many of those fit inside of the larger box. So if we're talking about books, right, and we have a book that's 80 cubic inches, and we know that a larger box holds, I don't know, we'll say 10 of those books, then we just multiply 80 times 10 and we can see that the larger volume would be approximately 800 cubic inches. All right, take a look at lesson 11.7. Let me know if you have any questions. Good luck.